Hello everyone. In the previous 7 chapters, we briefly described the properties and working principles of G. However, some aspects, such as the changes in G connections and the accumulation of G energy, were not explored in detail, as they rely on the knowledge we will discuss later. Up to this point, our understanding of G remains superficial, so it is necessary to re-examine it from the most detailed perspective. Let's start with the generation of G. Assume a newborn baby has just been born, and their postnatal G is almost non-existent. We can only say almost because even during the fetal period, external stimuli can form a small amount of postnatal G. When the baby opens their eyes for the first time after birth, the visual nervous system starts working. If we place a stuffed dog in front of their eyes, this will be the first thing they see. The visual signal of the stuffed dog is then transmitted to the brain. Where in the brain does this signal go? This depends on the brain's material pathways and the distribution of innate G. We are not sure of the exact location, but when the visual signal passes through the brain tissue, it initially forms a visual sub-G. The baby's first encounter with the stuffed dog might make them curious and open their eyes wide, or tense up and cry. This is because the input signal, after being transmitted, causes a type X activation of the innate G connections. The first sighting of the stuffed dog initially forms a visual sub-G for the dog, and through transmission causes a type X activation of the innate G connections, producing a type Y signal, which is a G wave. This G wave leads to emotional behaviors such as opening the eyes wide or crying. These two behaviors are relatively vague approach avoidance responses. Now, a question arises. Does the visual sub-G form first, or does the type X activation of the innate G connections occur first? Or, to put it another way, is there a sequence in the transmission pathway between the visual sub-G and the corresponding set of innate G connections? Think about it and remember this question. Currently, we know that the baby's G for the stuffed dog includes only a experiential G, which consists of a visual sub-G and an innate sub-G connection. Let's assume the baby's first reaction to the stuffed dog is tension. If we notice the baby is tense and immediately remove the stuffed dog, the baby's tension will likely ease. Why? Because the visual signal input is missing. The innate sub-G connection is no longer activated by type X. The emotional G wave is not produced, and the baby's crying gradually stops. If we then place the stuffed dog back in front of the baby, they will likely start crying again. This is because the visual signal is re-inputted. activating the already formed G for the stuffed duck. If we currently leave the stuffed duck in front of the baby without removing it, regardless of how much they nag and cry, and they wake up to see the stuffed duck every time they open their eyes, what will happen? The baby will adapt to the situation of having the stuffed duck in front of them. In common terms, the baby will become desensitized. This is similar to showing a calf that has been bitten by a tiger. Pictures of tigers continuously. Initially, the calf will be very scared, but over time, the fear will decrease. Why? Because the new environmental feedback signals cause the original reaction mechanism to be reshaped. Essentially, the original experiential G activation did not result in the expected danger, and subsequent relatively safe environmental feedback signals form the new experiential G. The original G connections fade away, and new G connections are formed. The stabilization of these new G connections requires multiple seamless sensory G waves for reinforcement. That that desensitized state is actually a kind of new birth, a brave and calm new birth. Note that the concept of expectation is mentioned here. What is expectation? To give a hint, expectation can be seen as a sub-G wave which can be formed when the original experimental G is generated through cognition or even inherited as innate G from the mother. Let's continue with the tense baby. If after the first encounter we do not show the baby the stuffed duck again, and one day we bring a toy that looks very similar to the stuffed duck, it is likely that the new toy will trigger the baby's tense reaction. If the new toy is just the original stuffed duck with a cloak, the baby might not recognize it or might think it is something else and form a new object G, showing a curious reaction. These two situations, one of ambiguous recognition and one of different recognition, both involve the interaction between visual input signals and the activation of corresponding G. If the similarity reaches a certain level, it activates the G. Otherwise, it often shifts to the activation of other similar G. We call this recognition pattern similar activation. In the next chapter, we will analyze this recognition interaction in detail. Just like the baby's ambiguous recognition and different recognition, both can lead to errors, mistaking the false for the true and the true for the false. When we recognize something, we engage in similar activation and constantly face these two types of errors. The existence of these errors is a necessary condition for all deception, blindness, illusion, and mental disorders in the world. In the future, we will analyze the enormous destructive power of these two errors in the context context of mental disorders. Mistaking the false for the true and the true for the false are also two types of error in statistics. Therefore, current scientific methods still can eliminate the deficiencies in our recognition of things. So, these are all the things today. See you next episode. Bye bye.